recording again, and we'll resume. Does anybody have any questions before I start? We doing all right? Super good. Glad to hear it. All right, we left off. I was showing you the gateway drive settings. Now we'll go look at the subscriber or follower or whatever you want to label it as settings, or member, I guess, to follow along with my example. So I'm going to go right back into the same menus we just looked at. But then, there again, I'm using a Digitex today, so it's 302. All right, so there we go. Now I'm going to close this one. And then I'll go to my subscriber. I'm online with it. And then I'll go to Ethernet. Now, there's some things I want you to notice here. First and foremost, is this drive clock synchronized to the Grand Master? Yes, it is. That is oftentimes overlooked. People want, they say, oh, my messaging's not working. Why? What's going on? Well, you want to look here to see if, in fact, this drive is part of the RTMoE network. Synchronized means yes, it is. And here is the deviation in terms of messaging between the Grandmaster and this subscriber drive. And as you can see, we're in the single nanosecond range in terms of messaging. That's to be expected. Yes, I'm here in an office environment with, not a lot of noise being generated or anything like that, but that's the kind of performance that you can expect when you're using this protocol. So let's look now at the menu 2 settings. So the thing that's important is down here, gateway mode. Go back to my slide here. Oops. There it is. Gateway mode, right? Well, I don't care about Ethernet IP again, so I'm going to skip over that. But if I go to parameter 25, I want to make sure that this one is set up as a switch. So I'll come down here. So that's default. You don't need to change anything. So this is a switch now. But I do want to make sure that I enable VLAN. If I don't do that, I won't be able to receive messages coming through the gateway that have a VLAN tag. So I have enabled VLAN, and the VLAN ID is 1 to match my gateway drive. So that has to be enabled, and that has to match what I'd set up for my producer drive up here. So in terms of menu 2, that's all we have. Now, let's go look at menu 11. So I'll switch down here. Now, the first thing we do is to make sure that this drive will never be the sync master or the Grandmaster. And to do that, I've just disabled arbitration by setting that parameter to a value of 0. So that's very important. And as you'll recall, our gateway drive was on time domain number 0. So I want this drive to also be on that same time domain. So therefore, I have that parameter set to 0 as well. Now that's default, so I didn't have to change anything. I did have to change that. By default, everybody can be a sync master. So that's the only parameter I changed here in this menu. All right, so that's the member drive settings now. When you have made changes to slot 3 or slot 4, what you need to do is reset the protocol, right? So that's done in slot 4, menu 0, parameter 7. So let's go look at that. Or slot 3, in my case. Right? So to do that, what we're going to do is we're going to come over here now to the parameters. Menu 0 is going to be right there. So let me rephrase that so you are clear. What you're looking at here, that's menu 17. Well, it's menu 17 because it's slot 3. You know, if I had a encoder card in the expansion slot 1, that'd be menu 15 on my Digitax. If I had something else in slot 2, that'd be menu 16. But because the Ethernet slot or factory fit module is considered slot 3, menu 0 parameters are found in menu 17, which is a little confusing. But here's the reset I was referring to right there. So once you've made your changes, you're going to want to reset by clicking that on, and it will turn itself off after it's reset. So again, once you've made those changes, you reset the protocol, right? So that's actually menu 17. I should just say 1707 in my case, not slot 4. It's 1707. Save the parameters in the drive, right? You know, the usual, right there. And then as the last step, it's not a bad idea to come back here and do a reset. It's not so important when you made those changes I just did, but when we actually start setting up messages, I'll need to do that. So right now, both drives are synchronized. I've got the clocks are synchronized. I've got a gateway, and then I've got a single subscriber out here. So we're looking good at this point. Now, what I'm going to demonstrate today is what's called easy mode links. Right? What we're going to find out is there's two ways of using these links. Easy mode being, well, the easiest way. And then tomorrow, what I'm going to show is the advanced link editor that's part of Machine Control Studio. It's a graphical tool that's used when you're using MCI 210 modules for your network as opposed to the standard factory fit modules that I'm demonstrating today. So an RTMoE easy mode link consists of a contiguous group of drive parameters. So what I mean by contiguous is the parameters that you'd like to share amongst the network subscribers has to be arranged into a group of consecutive parameter numbers. So what I can't do is send, I don't know, the feedback position, which is menu 302, the drive enable status, which is menu 629. The parameters that you want to use as part of one of these links have to be in a group of consecutive parameters. So you can do that by mapping parameters into menu 0, 18, 19, and 20 on a base drive. And when you're using an MCI module, you'll find that there are additional application menus 70 through 79. So let's have a look at that. Right, so I'll go back here. So menu 18, right? So what I can do here is I can map my parameters here as long as it's an integer data type, right? I could click there and map my parameter that I want to send. And contiguous means that I have to use a block of them all in a row, like so. So there's menu 18, 19, same kind of thing, right? If I scroll down, there's bits, there's long integers. Those are your power down long integers, right? Menu 20, same kind of thing. Now, menu 0 is what a lot of people will do if they're sending, if you have a lot of traffic or a lot of data you want to share. And let me show you what menu 0 is all about. So menu 0, you can see menu, and maybe maybe you don't know this, but menu 0 is a collection of parameters that are taken from these other menus and assembled into menu 0. It's called the quick access menu, quick setup menu, I guess. So this menu 0 is configured using menu 22 that you see right there. So if I open menu 22 now let's remember the menu 0 parameter 1 says minimum reference clamp. And then let's go look at menu 22. So menu 22 parameter 1 is the setup parameter for menu 0 parameter 1. So minimum reference clamp comes from menu 1. Menu 1 parameter 7 is therefore an alias for menu 0 parameter, I had that backwards. Menu 0 parameter 1 is an alias for menu 1 parameter 7. Now if I go look at menu 0 parameter 10, I expect to see speed feedback. There it is. So you see the relationship between menu 0 and menu 22. You can customize this to your heart's content. If you don't want to see speed feedback, well, okay, make it 0. Right? Save. Reset. And now let's go look. See? 911. So you can customize menu 0 to include only those parameters that you want to see or that you want to provide access to. But when it comes to messaging, if I scroll down here, look at all this. I can literally wipe out as many of these parameters as I'm not using, and these become excellent candidates for my network messages, because the other thing about menu 0 that you don't know is all of the parameter values that are stored in menu 0 are automatically saved to flash memory. So on a power down, the values of any parameter in menu 0 are going to be retained on power up. So, literally you have 79 parameters that you could map to menu 0, and then that's what you'd use for your block of contiguous messages. Now, I don't have that elaborate of an example set up today, but just so you understand that that's very commonly done when you want to share a large amount of data from one drive to another. So there's two ways to create links. We're going to use easy mode, and then tomorrow I'll show you how to use the graphical link editor, advanced link editor in Machine Control Studio. So easy mode links are configured using the menus found in slot 4 for an M700 or slot 3 for Digitex HD, and specifically menu 10. Each drive can transmit up to 3 easy mode links and receive up to 3 easy mode links. Each one of those links can contain up to 10 parameters. So therefore, I have a maximum of 30 easy mode parameters out and 30 easy mode parameters in per drive. Hopefully that is clear. So here are the individual parameters in menu 10 that we're going to be configuring for each one of those 3 links. That's showing transmit link 1. So let's go look at what those parameters are now. First thing is the link profile, which is menu 10, parameter 10, for transmit link 1 anyway. Here's where you decide whether that's a standard message or a synchronized message. So back in the beginning of the presentation, I said there's 3 message types: cyclic synchronized, cyclic non-synchronized. So parameter 10 in menu 10 will make that determination. If it's not mission critical, well, make it a standard link. If it is mission critical, make it a sync link. Parameter 11 is the link number, right? So, generally, 0 means that the transmitted link is disabled, but you can choose any number for the link between 0 and 255. Parameter 12 is where we're going to determine the source parameter. This is a transmit link now, so it sets the number of the first parameter in the block of contiguous parameters being transmitted using this link. So 1811, menu 0, parameter 10, 2001, whatever you're going to be sharing with the members of your network, this is the first parameter in that block of parameters for link 1. Then we have a parameter count. So here's where the contiguous part comes in. The quantity of subsequent based on the source parameters to be included in this message packet. So you can have a minimum of 1, which is the parameter of source itself, or up to 10 total. So if I've chosen 1801 as my source, and I have 5 here, then my packet is going to include the current values of the parameters in 1801, 2, 3, 4, and 5. So those are the parameters required to set up a transmit link. Now, the transmit link transmission type. This is the method of message transmission for the link, and your options are broadcast, which, as the name implies, sends that packet to all subscribers on the network. Here is where you need to be very careful. This is where network design comes into play. Broadcast messaging, of course, is going to consume the most bandwidth, so you do have to be careful. If you only want to send the message to one member of the network, we'll use unicast then. And finally, multicast. Our Ethernet switch, our factory fit Ethernet, supports multicast groups. There are 10 groups available. So with multicast, you can send that packet to only the subscribers who are part of the same multicast group. And again, we have 10 groups available. So if you've chosen the unicast as the type of message delivery here, if you've chosen that for parameter 14, then you need to enter the IP address of the subscriber here in parameter 15. So in other words, where's that unicast message going to land? Who's going to get it? And then finally, we choose the message rate. So 0 is disabled to 100 milliseconds. Now you may recall earlier that I discussed cyclic message transmission in the microsecond range. That is not an option with factory fit modules. about the minimum you can go down to is 4 milliseconds, I would say. That's a safe message transmission rate. So again, if you want to get down in the microsecond range, which I'll show you tomorrow, we use Machine Control Studio and an MCI 210 to do that. Transmit parameters. Now, what about the receiver? What about the subscriber? Well, again, menu 10 parameter 40. Let me show you that. Right, so let's close all this hoopla. All right. So I'm going to go to my transmitter, which I've labeled producer, Ethernet, and let's look at menu 10. There it is. Right? So, transmit link profile, link number. So here's my transmit 1, transmit 2, transmit 3. There's my links, my 3 transmit links. Now starting down here, there is my receive link. So what I'm going to do is now we'll look at the subscriber, Ethernet, menu 10, starting down here. So this is the guy that's going to receive the messages. So the first thing is the profile, and it has to match what the transmission link is doing. So if you're transmitting a synchronized link, you better be prepared to receive that link as synchronized on the receive side. By the same token, if you're sending transmit link number 1, you should be prepared to receive that same link number. It has to match the TX link number from the producer axis. So that's pretty straightforward. Now, because we're the receiver, this parameter 42 in menu 10 is saying, well, what am I going to do with that? Where am I going to store that parameter that's being sent? So here is you're going to flag the first parameter. If there's more than one message coming on the link, then you flag here the first parameter number in the block of contiguous parameters that are going to receive that message link. So if I'm sending 5 messages from 1801 in the transmitter, I'm going to need to receive 5 messages in the receiver. So this is the first parameter in the receiver, and then the other 4 parameters contiguously will be populated with the other 4 transmitted links. So that must match what the transmitter is, this must match the parameter count. If I'm sending 5, I have to receive 5. And I have to put those 5 here first. So destination parameter, and then the number of subsequent parameters that will also be included in that link. And then the source type. This depends on how the producer is sending the message. So if he's sending it as a direct message, then I'd choose direct. If I'm going to be part of a multicast group, then I'm going to receive it as a member of a multicast group. So I would match the multicast that the subscriber is sending, or the producer is sending. And then there's an option for local when I'm receiving from the factory fit module on a host drive. Right? So that's a possibility as well. And then finally, the timeout. This is a watchdog in milliseconds during which a message must be received. So let's go back and look at Connect quickly here. So here they are, timeout. Now what I'm going to describe next in the slides is the timeout action. This is more important than what you might think. What am I going to do as a receiver or as a subscriber in the event that the watchdog timer elapses without a message being received? How am I going to handle that? Well, the option is to trip. So if I don't get a message, the drive itself will trip and it will have what's a slot error. So in my case with Digitax, it'll be SL.3.ER, a slot 3 error. I can clear output. What that does is the values for all the messages received on this link will be set to 0. Or I can simply hold the last. Retain the values received on this link from the last successful transmission. Excuse me. Of those, I would highly recommend trip. If there's something wrong and I'm relying on mission critical data, well, I want to know that that message has not been received or that packet is not being received. So I generally choose to trip the drive if the message, if the watchdog times out. Now, if you're using an MCI module, we have events. The MCI module, if you went to my Machine Control Studio training, it has 4 event tasks. Well, that's what we're looking for here. If that trips, or if we get a watchdog timeout on transmission, I can also initiate an event task. So that's not applicable to what we're doing today, but know that that's an option. And then finally, the event type is the task number for the MCI control module, and there's 4 of them. So if I were using an MCI module, I could flag an event task when it's tripped, and the code in that event task would then maybe clear all the digital outputs, put the machine in a safe state. But again, we're on a base drive, that's not an option. So that's the nuts and bolts of an easy mode link, but now let's put it into practice. One of the more common uses of this is to pass the position reference of one drive to another in order to synchronize the speed of the 2 motors. If you've ever done a master-follower type of application before, well, using traditional means, you would have a master encoder somewhere, and then you'd wire the encoder pulses out of that encoder in a daisy chain fashion to all of the followers who are going to be following that speed reference. Well, that method is fraught with disaster, potential for disaster. You end up losing pulses, gaining pulses, noise, cabling, all that sort of stuff. Using RTMoE, we can pass that signal at very high speed using our RTMoE protocol over Ethernet. So that's what I'm going to demonstrate today. And there are 2 options on how to do velocity synchronization in the follower. Okay? I can use menu 13, which is called the standard motion controller, and the follower, which is what I will do today. But I can also use gearing in the AMC. I can also use EGB mode with our advanced motion controller to do velocity synchronization in the follower axis. Today I'm going to use menu 13 just for simplicity. So here's my demonstration. I've got a producer axis and a subscriber. Now again, you don't start your drive commissioning by setting up easy mode links, clearly. You'd go through and commission the drive, motor, feedback, get everything running smoothly like you'd like it. Then we'll come and do this messaging. So after commissioning, I'm going to configure the transmit link in the producer. Then I'm going to switch over to the subscriber, and I'm going to configure menu 13, which is the standard motion controller here. then I'm going to configure the receive link in menu 10 on the subscriber. So that's what I intend to demonstrate here. In terms of what I'm going to be transmitting for the producer here, I'm going to be sending menu 3 parameter 29, which is the axis position as measured by the motor encoder for this axis, which is attached to P1 on our high density 15 pin encoder connector here. So I'm going to send that position down to the subscriber. And this is an example of a mission critical link. So I'll configure the producer to become a gateway, and I'll also enable VLAN. So let's start with step 1, which is the producer access transmit settings. So here are the values of the parameters that I'm going to be setting up in menu 10. So let me go and do that now. All right, now this is the subscriber. We're coming to that later, so I'm going to close those. And we will focus on this guy. Parameter listings, menu 10. So this is my producer. So I'm going to say this link is going to be synchronized. That's a synchronous link now. And I will go back to my show. That's transmit link 1. Here's the source parameter, which is menu 3, parameter 29. Notice you can send data or parameters from modules also in other slots. But I'm going to just stick to slot 0, which is the base drive, menu 3, parameter 29. That's the only parameter on this link. And because I have only one drive in my network, well, I'm going to send that as a unicast message to my subscriber. And again, about the minimum practical message rate for base drive, factory fit modules, is 4 milliseconds. So that's how I'm going to configure my transmit link. So this is link number 1. So that becomes 03029. Enter. So that's what I'm sending. I'm going to send one parameter, unicast, to the IP address of the subscriber, which is right there, 192.168.1.30. And then the message rate, we're going to make that 4. Just like that. All right. Now that I've done that, we're going to reset slot 3 using the reset icon on the Connect dashboard. Well, I'm going to begin by resetting the protocol. 3.10.02 to on. Actually, I'm going to begin by saving parameters in the drive. Then I'm going to come up here to this reset, which resets the protocol. Now watch what happens. Goes off by itself. Then I'm going to finish right here with this reset. And it'll dip offline for a moment. It takes about, and this is important too, it takes 20 to 30 seconds for, once I reset that, to bring things back online again. So you can see here we're still active here. Right? And if I wait there long enough, it'll come back online. But let's move along. So there is my transmit message. And that's all I need to do in the producer. So the rest of this now will be the subscriber axis. And I'm going to begin here by setting up the standard motion controller in the subscriber. So let's go look at that now. Well, come on now. There. Sometimes you have to do that. It should pick up on its own. But you can see we're back. I'm the Grandmaster. And away we go. So now let's go to the subscriber. Here. And we're going to begin with menu 13 here. All right, now let's look at those parameters. First thing I'm going to adjust is where's the reference for this is where is the gearing reference going to come from, synchronization reference. And by choosing local, what that means is that rather than having the reference come from an encoder on a module or an encoder tied into the high density 15-pin port on the drive, the reference is coming in locally over the link we're going to be sending. So I'll begin by changing 1304 here from P1 drive to local, like that. So just like any other motion controller, that's the command signal. Where's the feedback? Well, that is coming from the motor. So I'd leave that at P1 drive. So it's command, feedback. Right, there is the gear ratio. And I'll leave it 1:1. I could adjust the gain term if I wanted to stiffen the loop. This is what has the effect of enabling or disabling the motion controller. Whenever I change this value in parameter 10 to anything other than disabled, now it's going to the motor speed, or the motor speed in this case, is coming from whatever I'm sending. So once this is enabled, I'm not going to be able to run from an analog speed reference or a preset speed reference or anything else. It's going to come from the link that's being sent by the producer. So there's different modes for this, and I'm not going to go into the detail on that right now. If you look at the help file and connect, it'll explain what this is. But I'm going to choose non-rigid speed feed forward as the motion control mode. So let me go there. Oop. So here's my options. I'm going to choose non-rigid speed feed forward. I have an absolute encoder, so I'm going to enable absolute mode. Right there. Now this is not a maximum speed. All right, that's confusing. This is the maximum amount of speed command that the drive will use to correct for position error. All right, so this is like, you know, if it's lagging, it's going to add up to 150 RPM on top of the command to try to reduce following error. So that's not a speed limit, even though it says it is. Okay, so the rest of this stuff I'm all going to leave at default. The last thing I'm going to do is come to parameter 24. I have a single turn encoder on these demos, so I'm going to turn this on to enable the revolutions part of my position word that's coming over. So I'm going to turn on 1324. Like so. Now the real reason that I set the transmit link to 4 milliseconds is right there. That's the sample rate. There's no point in sending the reference faster than the drive can handle it in the first place. So 4 milliseconds is what I'm going to leave that at. So that's menu 13. All right. Now let's set up the receive link. But before we do that, I want to make sure that the settings in menu 2 are as shown here. In other words, I have to have the VLAN enabled because it's enabled on my transmit or my producer, and I have to have VLAN ID 1. So let's go look at that quickly. All right. Now, gateway mode is switch. That's what I want. VLAN's on. VLAN ID is 1. So that's all good to go. Now here are the receive settings for receive profile 1. Right? So there again, I'm sending a synchronous link, so I need to be prepared to receive that link. Right there, as synchronous. I'm sending link number 1, so I have to receive link number 1. Now the destination parameter, I'm sending the reference to menu 13, parameter 21. So let's look at that. Oop, not there. Here. 1321, standard motion local reference position. So I'm sending the position of the producer right here for the subscriber to follow. And again, that's what local means up here. I'm only producing one message, so I'm going to receive one, and it's coming directly because it's being sent as a unicast message from the producer. So let's go do that. Menu 10. All right, so I'm going to go down, start with parameter 40 right there. Sounds like we have incoming. So that's a synchronous. Receive link 1. Okay, menu 13, parameter 21. Parameter count is 1. It's coming to me directly. So that's all I need to do. I'm leaving all the trips and all that. I want it to trip, which is the default, and that's the watchdog. So I'll just leave that as is. So that's my receive link. Now what I'm going to do is save parameters in the drive, reset the protocol, reset slot 3. So I'll come in here, save parameters in the drive, come up here to reset the link. Okay. Then finally, I'll come here and reset it there too. Okay. Oop. Now watch this. Synchronized, no. Watch this fall now. And again, it takes 20 seconds, 30 seconds for this to happen. See, it's decreasing. There we go. We're getting there. Not quite yet. Oh, now we're getting down there. Okay. I expect this is going to say synchronized yes pretty soon. There it is. So now we should be good to go. So to make sure we are, I'm going to look at menu 11, parameter 8, module synchronized. That's what you were just looking at a minute ago. It should say yes, but we'll check. Yes, module is synchronized. Now, back in menu 10, there are two more parameters. Parameter 5 will tell you if your messaging network configuration is valid. Menu 6 will confirm that the link is operational. So you always want to check those two. So I'll come in here now. Yeah, on. And then finally, I'm going to check the status of the link, which is parameter 49, receive link status. And what you want to see is OK sync. So there it is. And there we have it, OK sync. So at this point, I should be able to run it. And there we go. You can't see it, but trust me, maybe you can hear it. So I'm following along quite nicely. If I go look now here, you see this is in counts over 65,535. So even with the default gains, that's following along very closely. And the last thing I will do, or I'll show you, is this. If you look at it, use our CT scope software, you can graph out how well the velocity following is performing. So the yellow trace is speed reference, that's coming from the master. Red is speed feedback, and green down at the bottom is the speed error. So you see I get a pulse of error when I'm accelerating, and I'd see another one if I were to stop. And that's because I have an acceleration rate of 200 milliseconds in my subscriber. So if you want it to follow without any hesitation, whatever the master's doing, you would go in to menu 2. Let's see. I would come in here, speed ramps, and I would disable the ramps. Otherwise, whatever you have here is going to come into play when it comes to following the master. So, that's all I have for you today. Does anybody have any questions? I'll stop this.
Nope, that was pretty concise.
Okay. Good. Anybody else? All right. Well, thank you again for attending. I appreciate it. And then tomorrow I'll be back same time, and we'll look at how to do the same sort of thing with Machine Control Studio. So thanks again, and I will see you tomorrow.